In demos 1 and 2, we'll run all 6 cars. Then in demos 3, 4, 5, we'll run 4 cars, then 2 cars, and then 1 car. Then later in special demonstrations 6 and 7, we'll run 2 cars and then 3 cars using a higher yard speed of 4 versus the yard speed of 1 that we used for our main demonstration with 6 cars. Then later in the video, we'll take a look at some of the off-the-shelf hardware we can use to build these control units to control these streetcars or trains. Recall in earlier video 834 shown here, we kept 2 cars stopped in the yard while 1 ran. In this video you're watching now, we're always running all the cars. Hello, I'm James Ingram for MidwestTractionHub.com, which is part of the AutoControls-dot-org website and also part of the TrainProgramming.com website. In this video, we're going to be controlling 6 MTH PCCs on 1 loop of track with no blocks and a single detector using an NCE DCC programmable train controller to automatically control them. Okay, the system is turned off. First thing we're going to go is go over there and turn on the system. Here's our on button here. That'll power everything up. We want to wait about 10 seconds or so because those cars have capacitors in them and they pull a higher current while they're charging their capacitors. Here we have our push button. This has been used in several previous videos. It says push 1 second and release to start the cars. This is like if this is on a public display, the public can push that button. And observe our front car is that gray car back in the rear. And notice it's about in the middle of the straight section back there. Then our number 6 car, the rear car, is this dark green San Francisco car parked here. So let's push the button and start them up.
Hey buddy, have a nice day.
We got a Z-Stuff infrared detector right here. Notice when that car goes past it, that light will turn to red briefly. And when that happens, that car is set down to a creeping speed, and the second car, which is that green car coming there, that got speeded up to speed 6. What we're doing, we've got 6 of these MTH Proto 3 PCCs, and we're running them at speed 6 on the main line, like the yellow car coming across, that's running at speed 6. When they go past the detector, the relay closes on the detector, which notifies the controller, and that slows them down to speed 1. So what we have is 5 cars in the yard at any one time, and the 6th car is out on the main line. Now there's our 5th car. That yellow, that's a Cincinnati car, I believe. That's running at speed 6. And again, when it goes past the detector, it will slow down to speed 1. Now here's our final car, the green, dark green San Francisco car. If you notice closely, this one doesn't blow its horn because there wasn't enough space in our programmable controller left to put the horn blowing routine in. Now notice they all stopped right where we started them, basically, because our what we call the repeat switch is closed. They'll make a single cycle. So if this was on a public display, they would sit there and wait till somebody came along and pushed that start button again, and then they'd start up. So we can push the button and run another cycle, but let's do one first one thing first. Let's mess up the spacing. Now we're going to run them again, but we're going to first deliberately mess up the spacing a little bit. I'll pull this one around a few feet down in the main line. I can do it without derailing things. And I'm going to pull this one forward also, just deliberately getting them out of position, and the system should put them back into position. Now I'm going to turn off the horn. I'm going to close what I call the repeat switch, so they should run continuously. The spacing between cars is established by a 3-second time delay when they go across the detector, plus however much the car creeps before the next one arrives. So you can see, looking at the gray one and the one in front of it, they're closer than normal because I deliberately messed up the spacing, but the system will recover that spacing in a minute. Worst case, one car would bump and push another car, but we figure since it's speed step 1 they're running at in the yard, it's no big deal if one does bump another one at that slow speed. Now there's our 4th car coming around, going into the yard. The 5th car back in the rear of the yellow Cincinnati car, that just speeded up coming into the yard. These are MTH, by the way, these are MTH Proto 3 PCCs. The Proto 3, as you probably know or may know, can run on DCC, which is how we're controlling them here. You have to add a switch to run them on DCC, or you have to go in and cut a wire, but they do have the capability of running on DCC. And our DCC programmable controller is made by the NCE Corporation in Rochester, New York. Now note we're back to running the first car, the gray car, and you can see that they more or less regained their normal spacing at this point. We're making a second cycle, but you can see it pretty much recovered its spacing. Now let's go over and I'll open the repeat switch and turn the horn back on. The little program that's inside the controller runs all 6 cars, and then it checks to see if what I call the repeat switch is open or closed. And if it's closed, it goes back to the top and runs all 6 of them again. And if it's open, then it stops and waits till somebody pushes the push button again. And actually, we can run any combination of these 6 cars. We can run all 6 like we're doing now. We can run any 5, any 4, any 3, or any single car. The only real restriction is we have to keep them in the order that they're in. The gray one, if it's on the track, has to be the first car, and that green one following the gray car, that has to be the second car if it's on the track. Now there's our last car, the dark green San Francisco car coming in across the detector. There, now you can see we covered all their spacing from when we messed it up, and they're sitting and waiting for the push button to be pushed again. As I may have mentioned, there's no blocks in this system. It's just a simple continuous loop of track. Our detector is a Z-stuff infrared detector. And this thing operates when something blocks it like that, it changes to red, and then it pulls back to green. And it's not even attached to the track, it just sits alongside of it, so we can move this thing any place we want. Now the next thing we'll do is remove cars 3 and 5 and run this with just 4 cars on the track instead of 6. There's car 5. And here's car 3. So we just have 4 cars on the track. And I have to open the corresponding switch. That's a switch for car 3, and that's a switch for car 5. And we'll push our start button as before.
Hey, buddy.
Okay, the first car, the gray car, just crossed the detector. Now that's the second car coming in, the green car. Well, that's the fourth car, the yellow San Francisco car coming down the straight. Now that's the last car, the dark green San Francisco car. Let's hit the repeat button if we can. It was too late, but if we start them up again. If we start them up again, you can see everything's pretty much adjusted, and the system will happily keep running those 4 cars for as long as we want to keep running them. Now what we'll do is we'll take off the first car and the 6th car and just run the remaining 2 cars. And again, I have to open the appropriate switch. That's a switch for car 6, and that's a switch for the first car. And we'll push the start button. Now with 3 cars or less, you could use the method we used in the earlier video, 834, which actually stopped the cars when they came across the detector, like observing that the green one there that's creeping in the previous video, 834, where we were running at the Toy Train Expo. We stopped those cars, and you can do that if you have a total of 2 or a total of 3 on the track. That when you get above 3, there's really not enough room in the programmable controller to handle all the instructions for running 4 or 5 or 6 cars that way. This is a simpler method we're using here. We don't stop them, we just slow them down to speed 1, and by doing that we can, as we've seen earlier, we can run up to 6 cars. And you can see that system will just happily keep going with 2 cars on the system. And eventually they'll close the spacing up so the 2 cars will run pretty much the normal spacing between cars. Now we'll take off one more of the cars, so we'll be down to just running a single car. And I need to open the switch for the car that I just removed. Now we're going to be running just the 4th car. And actually this runs this will run pretty continuously, almost like we're just running one car normally without using a control system. The only thing you'll notice is when it comes past the detector, it'll slow down to speed step 1 just briefly. There you can see it slows down just briefly and then it takes off again. And what happens, the processor, the programmable controller, slows it down to speed step 1, and it's checking the other cars to run, except there are no other cars to run, so it goes around the loop in the program and comes back to this car and starts it up again. Now I'll open the repeat switch. So that car will come in and stop, and again it'll wait till somebody pushes the start button and it'll take off again. So you could use this system even for a single car on a display. What the programmable controller would do for you is give you a system that would run the car when somebody pushed the button, but then it would stop when nobody was pushing the button and wait, rather than just running around continuously when nobody was there. There it is again. Now it's just going to sit there and wait till somebody comes along and pushes that button again. The other thing we should mention here, even though we've been controlling these cars automatically using the programmable controller, we can still plug a cab in here and control them manually. We just need to make sure the controller's not sending commands. Right now it's idling. So I'm going to plug this cab into the cab bus port that's on the programmable controller. And I can select, probably can't get it on the camera, but I can select a car like 1104 and tell it to start up. Hit the reverse button, back up and reverse. So we can control these cars manually as well as using the programmable controller. Again, I tell people to think of the programmable controller as like one of these cabs with a robot controlling it, and you don't want it giving commands at the same time you're giving commands with this thing. So we have to make sure the programmable controller is either turned off or idling it as is now, so we're not sending conflicting commands. Here's another variation we can do with just two cars. Is run the slower car that's in the yard, run it at speed 4 instead of speed 1. Now right now the blue car on the main line over there, that's running at speed 6. That car in the yard is running at speed 1 right now, but as soon as the detector is crossed, the controller speeds it up to speed 6. That yellow one's running at speed 6. The blue one in the yard is running at speed 4 instead of speed 1, so it's still moving at a decent rate of speed. Now when that yellow one crosses, it gets slowed down to speed 4, and the blue one over there gets speeded up to speed 6. So say this blue one's trying to catch the yellow one because it's faster. It can't do it because as soon as it gets to the detector, it gets slowed down and the yellow one gets speeded up to speed 6. So we got enough of a speed difference that'll always keep the faster one from catching the slower ones, but we have both of them moving at a decent rate of speed. This is just an option you have when you're running only two cars on the track. And if we go and open the repeat switch, as before, whenever the front car gets around and crosses the detector, they'll stop. In this case, the front car is now the blue one, so they'll stop, and again they'll sit there and wait until somebody comes along and pushes the button again, and then they'll start up. And again they'll resume operation just like they were a minute ago. If you really wanted to do this all the time, you could set the initial conditions so the yellow one would start up at 4, but we did this just as a demonstration. Now here's another variation of running the slower cars at a faster speed. This time we're using 3 cars on the track. The 2 slower cars in the yard, which is the yellow and the green one, are running at speed 4. The gray one, which is on the Mainline, is running at speed 6. Now when it crosses in front of the detector, the controller will slow it from speed 6 down to speed 4. That's the gray car, and it speeded the green one up to speed 6. Now when it goes in front of the detector, it'll get slowed down to speed 4. Now the yellow one is running at speed 6. Now the yellow one just got slowed down to speed 4. In fact, everything stopped because the repeat button was open. I'll go close the repeat button and start them up again. And again, the gray one is running faster at speed 6. The green and yellow ones are running slower at speed 4. Now the gray car slowed down to speed 4, the green one's running at speed 6. These should stay separated because any car that's running slower will get a chance to catch up to the other two on the straightaway, like that would be the yellow one right now. It's getting to catch up. But any car that's running faster is going to get slowed down in the yard. So what this gives you basically is 3 streetcars in motion pretty much continuously. We just need to make sure that they finish blowing their horns before they get to the detector, because if they're blowing the horn, if the controller is sending a command to blow the horn, it won't see the detector go to ground, and it'll kind of miss the car going by, if that makes any sense. Makes more sense when you look at the instructions. Now we'll open the repeat switch in a second, and they'll complete their cycle and come to a stop again. Now I opened the repeat switch, and just to review, the repeat switch is just a switch that we use to ground one of the inputs, and we check that at the end of the routine to see whether to go back and run all 3 cars again or whether to stop running the cars. Now the yellow car is the last car, so when that crosses the detector, the controller will be at the end of the routine. It checked the repeat switch. That wasn't grounded, it was open, so it stopped things. And they'll sit there and wait for however long until somebody pushes the button again, and they'll start up. So this system also could be used on a public display. Taking a look at our components here, it's pretty simple. We got a simple loop of track, and out there on the far corner is that public push button we were using. Here's the Z-Stuff detector, and then back here we've got the NCE command station. This is a 5 amp system. NCE recommends using a 10 amp system for O gauge. I can get away with the 5 amp for 6 streetcars because they don't pull too much amperage, but the NCE does recommend the 10 amp system. If you've seen some of the past auto controls videos, we've used a power cab. You can use the power cab for 2 streetcars, even though it's not recommended. Once you get to 3, it gets a little iffy. And we'll take the camera off the tripod and go take a look at the controller a little bit closer. Here's basically the controller, and you can see this thing is there's what we call our programmable train controller. Actually, NCE calls it a MIDI panel. This is an Atlas number 56 switch that's used normally to control snap turnouts, like HO turnouts, but we can use it for the reset button if it's this way, and the start function if it's over here. Basically, this switch, when it's pushed in the start position, does the same thing as that public push button out there we were using. They're wired in parallel. You can have as many input switches wired in parallel as you want. Any all it takes is any one of them to ground the input, in this case input 1, to start the cars up. And then here we've got 3 Atlas 205 connectors, and these just allow us to connect these inputs to ground or not connect them to ground, whichever way they're pushed. If it's pushed toward where we're standing, it'll be grounded. If it's pushed away, like this is a repeat switch, it's open right now, it's pushed away. But in the past we've used some toggle switches, and these do the same thing as the toggle switches, except they're just a little easier to wire up because you've got basically one ground. Here's the ground wire over here. You've got one ground, and these things are all tied together, so it's a little easier to wire them up. And then this is just the power over here, power going out to the track and power going out to the Z-Stuff detector. The Z-Stuff detector, this is a DZ1012 detector, and there's a DZ1008 relay, and 2 of these wires going out. That's the red and the green wire are the power wires, and then coming back.
This is a number 67, 7th Avenue car.
The blue and the green and the black wire coming back. That's the relay output. When a car goes in front of this thing and it changes to red, it grounds the green wire to the black wire, which essentially grounds the input on the controller and tells it the car is there. This could also be a reed switch or an electric eye, or any means of just connecting those 2 wires together, the same as the relay does. Now we're looking at the control panel again. All the switches are open for the 6 cars. That means it won't try to run any of the 6 cars. But if we start the processor up, so to speak, you can hopefully see there's a surface mount LED there that's blinking red. And it's blinking about every half second. And what's happening is it's starting at input 1 and going all the way down to input 30, encountering a half-second delay statement, and then it's going back to the top because the repeat switch is closed, and it's starting down the bottom again. In other words, we're going down through all 30 inputs inside this thing's memory, which is roughly 120 commands, 4 steps per input, but it's not finding anything to do other than blink that LED. We're actually sending a dummy command to throw at a switch that doesn't exist, but when we send a command, it blinks the LED. Now there's another statement in there that if we close a detector, you notice that I moved the detector over here and you can see it's green. If I put my hand in front of that and change it to red, and you watch that LED blinking over there, you can see now it's blinking a lot slower because we've added a second delay if the detector's relay contacts close. That's a way we can verify the detector is being seen by the controller. Now if I take my hand away and it goes to green, you can see how it speeds back up again. Now if I put my hand back there, change it to red, it slows down again. And when it changes back to green, it speeds up again. Now if we open the repeat switch, it quits running. You might have seen there was a flurry of red blinks there. That's sending the commands to stop all 6 cars, the end of the routine. And we can repeat that. If we close the repeat switch, press the start button here, again we can see that thing is blinking every half second. Now you may notice the back of car 14 is sitting there. If I push the switch for car 14, it says run car 14. You can see it got a hold of car 14, so to speak, and it's running that car. So it'll run whatever cars have the switches closed. And here's the drawing for building this control panel. It looks pretty much like the picture of the control panel earlier. Actually, what I did is I put the parts on the piece of wood and photographed that before I added any wires, and then I put that photograph into a drawing program in Taglio on the Mac and added the wires to the drawing. But it just basically gives you where I ran the wires, and you can run these wires pretty much any way you want. I just try to do it the most convenient route. And again, you can see it gives us nine control switches we can use to control whatever this controller's doing. In this case, the one right here wasn't used. We only needed 8 of them, but it gives you 9. Plus over here with the Atlas number, these are Atlas 205 connectors. Over here, the Atlas 56, which is a momentary push button that has 2 positions. We have the start button used on this end, and you slide it over and push it down to do the reset. And here's space for a tortoise, a Circuitron Smale, which we didn't use in the demonstration, but there's space to have one in there to operate a status light. And this drawing will also be in the documentation directory at AutoControls.wordpress.com. Here's some other versions of these control units we've been using. This one right here is the one we've been using to run these streetcars, and this is one was used to run the streetcars earlier. It's almost the same. You can see we have 2 of these Atlas connectors, and then we used 2 toggle switches. Here we have a Schmale. This was used on the earlier video 834 that ran at the Toy Train Expo. This is a tortoise Schmale, similar to a Circuitron tortoise, but it has NCE components inside that you can control it with DCC. And we have this red-green light here we call the status light, and when the public pushed the button and the system started running, that changed from green to red, and we could tell them it doesn't do any good to push the button until it changes from red back to green again. So we basically called this thing a status light, and we used the tortoise, the Schmale, to operate it. And we have space on this board here to put a Schmale in there. It's not on this unit used for the video, but there's space where we could add one to add a status light to this control unit. And then back here is an earlier unit. Take the camera off the tripod here. Back here, this is the unit I've been using to run the point-to-point system, and here we've got a bunch of toggle switches. I think there's 3, 6, about 7 or so toggle switches, and they do the same thing as these Atlas connectors. You just ground one of the mini panels inputs to ground. It makes a little more wires though using the toggle switches, because you got a plus to run to the controller and you got a negative you got to run to somewhere. In this case, I ran it out here, so these things are a little easier to wire up. Then back here, and here's again another Schmale used to control the status light, which in this case is a red-green signal. And then back here is an earlier one. If you go back to the earlier videos, like 816 and before, we use push buttons. You can see this one has 4 push buttons here, plus there's another push button over here that connects input 1 to ground, and here's our repeat switch. So earlier versions of these control systems, we use push buttons to start little programs running within this controller, but it seems more efficient as we've experimented to have just one program running, and rather than push buttons, we use either the toggle switches or the on-off switches like this. You have like basically one program that runs from input 1 all the way to input 30 and checks everything, including the detector. Let's take a look at the flow chart for the commands for this system. This is basically a higher level way of looking at the commands. We start up at the top here where it says push start button, and that changes the status light green to red, and then we start the last 5 cars at speed 1. The first one will get started in the commands to run the cars. Then we have these 5, I'll call them decision blocks, these diamonds in green, which are the 6 decision blocks to run the 6 cars, and it goes down and checks each one of these if the switch for that car is closed or open. If it's closed, it runs the car. If it's open, it just drops through to the next box. So it can run any one of these 6 cars, and then it goes down to the bottom here, and it looks to see if the detector is blocked. This is a detector test. If the detector is blocked, it adds an extra second of delay. That corresponds to the test we did when we put our hand in front of the detector and it slowed down the blinking. Then this is a delay a half-second command. That just makes it blink every half second if your processor's cycling and no cars are selected. You apparently have to have some amount of delay in here, because if you don't have a delay at all and no cars are selected, the processor's just trying to process this loop at infinite speed, and it seems to quit. Here is our command to blink the mini panel LED, and again, going back to our demonstration where we had that thing blinking at a half second when no cars were selected, that's the command here that blinks. Then here's another decision block. Is the repeat switch open or closed? If it's closed, it goes around here and up to the top and does the whole thing again. If it's open, it drops through the bottom and it stops all 6 cars, and it changes the status light from red back to green to indicate the system is available again, and then there's an end statement that stops everything. Now let's take a look at one of the cars in more detail. The first one, I've diagrammed it out in more detail. Car 14, the first one that runs. Our first command is select speed 4. Select car 14, speed 6. That gets the car going. Then we delay for 3 seconds, and that 3 seconds delay is to make sure the Z-stuff detector's relay has gone back to the open position. If we don't have that delay in there and the horn's not selected, it may drop through the bottom and look for the detector being blocked when it gets to the detector. But if the detector is still closed from the previous car, then it gets confused and think it's this car's arrived at the detector when it's not there yet. At any rate, we delay that 3 seconds. Now we have a decision block. Is the blow horn switch closed? If it's not, it doesn't blow the horn. It just drops through the bottom and comes to this wait until the input is closed for the detector. If we have the horn switch closed to indicate we want to blow the horn, then it goes over here and it delays for about 6 seconds. That's to get the car out kind of in the middle of the run. And then we turn the horn on, delay 2 seconds while the horn blows, turn the horn off. So we come down, and we're down here to our wait till the input is closed for the detector. And when the car goes in front of the detector, which closes the Z-stuff relay, that becomes a yes, and we come out here and set the speed to 1, which slows the car down to yard speed. Then we go back up here and start looking at the second car. And rather than draw all this stuff for all 6 cars, which really wouldn't fit on the paper, we just put this, we just said run this car 1003 and run car 420 and so on. But each one of these cars actually does all these steps. And so, as I mentioned earlier, it can run any one of these 6, any combination, any 2, 3, 4, or 5, or none of them. But this is basically a high-level look at how the commands work. Let's take a look at the commands and documentation for this system. This is the first page. It just has some notes about the cars. This sketch here is a sketch of the programmable controller and what switches are hooked to which inputs. You can see these inputs here, 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 and here are for the 6 cars. this is the input that blows the horn or doesn't blow the horn. This number 9, input 9 is our repeat, what we call our repeat switch. If that's closed, it repeats another cycle, keeps running the cars. If that's open, it runs one cycle and quits. Our detector hooks into input 6. And then our start button hooks to input 1. And we've got a reset button hooked into the reset input, which is essentially input 31. And if we go to the next page, that's page 1. Flip over to the next page here. This is basically a tabulation of the little mini programs inside this thing that run each of the cars and what inputs they take up. These are the configuration settings for the mini panel, the way we're using it here. And then down here is our library. This is just like a cheat sheet of all the commands commonly used for automatic control. And the red is the variable, so you change what the red is if you want a different input. Like this says link to input 9. 9 is shown in red. If we want input 8, we put an 8 instead of a 9 there. Now page 3, this starts our actual program, and we call this initial conditions. This basically starts all the cars up. It starts the cars second through the last cars. That's car 2, 3, 4, 5, and 6. Starts those up at speed 1. We don't have to start car 1 up because the next thing we do is command it to start up at speed 6 if it's on the track. So going to the next page, these are the commands for our cars, and this is the first car here. And basically what we do, we select it. This happens to be car 14, the gray newer car. Select loco 14, speed forward 6, delay a quarter second times 12. That's 3 seconds. That gives it long enough to make sure it's past the detector. Then I'm going to skip over this part in blue. Then we say wait till input is 6 is ground. That's the detector. So we wait until that car crosses in front of the detector. Then we say speed forward 1. That's the yard speed, slows it down. And then we go on to the next car and we check if we want to run that one and do the same thing for the next car. And we do that for all 6 cars. Now going back, what here is in blue is the part that's for the blowing the horn. If you weren't worried about blowing the horn, you wouldn't need this stuff that's in the blue. But again, it checks an input 10 in this case, to see if we want to blow the horn. If it does, it runs a delay statement of 6 seconds to get out to the middle. The main line turns on the horn, delays for 2 seconds. That is to say, it blows the horn for 2 seconds, and we turn off the horn. So that's that. So this is the first car and the second car, and then going over here to this next page. This is the third car and the fourth car. And you can see I make these little sketches because this program isn't really complicated, but it's some bookkeeping and get yourself confused. So in each case, the car on the left here is the one that's heading for the detector, and that's the one we're commanding, because basically we're starting it up, running it until it gets to the detector. When it gets to the detector, we slow it down to speed 1, which is our yard speed. Then we go on to the next car. So that's cars 3 and 4. Going here, same thing again for cars 5 and 6. Go to the last page. This is our shutdown page here. It comes down here, checks input 9. If input 9 is closed, that is to say if we want to keep running, it goes back up to the top of the program and starts all over again. If input 9 is open, which means that's to say if the repeat switch is open, means we want to quit, it goes down here and it just selects each of the 6 cars, gives it a speed forward 0 command to stop them, then it ends the program. And one more thing, the detector test, right here we have a line that says skip if input 6 is open. That's a detector input, so normally that's going to be open. There's not going to be anything in front of it, but if we're testing it and we block it with either our hand or a car, then it adds another second delay, a quarter second times 4. It adds an extra second delay, so the thing will slow down the blink rate, and that was hopefully demonstrated in our detector test. We always have a delay of a half a second here, and we send this dummy command to Accessory 2000 to norm. That's just a turnout that doesn't exist, but it makes the controller blink when we send that command. That's what makes it blink every half second when the programmable controller is idling, as we showed earlier. And you have to have a little bit of delay in there. If you don't have a delay, that thing, with no cars on the track, it tries to loop at infinite speed, and it cuts out. It doesn't want to run at infinite speed, so you got to have some delay in there. One thing I forgot to mention when we were going over these commands for this last of the 6 cars, we ran out of space to put in the horn blowing routine. If you look closely at these numbers, it comes down here to input 25 step 1, and then we jump down here to input 25 step 2, the next command, and it goes on. These commands to blow the horn, you can see there's X's in the side because they're not really in the programmable controller because we ran out of space. That's why when we were demonstrating the 6 cars, the 6th one, which is that green San Francisco car, we couldn't blow the horn on that. All the other cars, we had the option of blowing the horn when we closed switch 10, or not blowing the horn when we opened switch 10, but there just wasn't space for those commands. Incidentally, if you were running cars that didn't have any sound, you probably wouldn't even need these horn blowing commands. You could take all these steps out for each car, which would free up a lot of space in the controller. You could conceivably even run 7 cars or maybe 8 cars if you had enough amperage in your command station. Let's talk more about programming this thing. I've got the instructions here. You can see this line, input 7 step 2, says speed forward 1. That's after we cross the yard detector on the first car, which is car 14, the gray one. It sets it down to from speed 6 on the main line. It gives it a speed forward 1, which is the yard speed. Now I believe this is set to speed 4 because the last experiment we did, demo 6 or 7, whatever it was, we were running the cars in the yard at speed 4. So this is probably actually a 4 inside the controller. Let's see if we can take a look. I've got the ProCab plugged into the programming port back here. It's almost out of sight, but it's into the programming port of the programmable controller. And what we will do, we have options here. I'm going to press option 2, review, and it says review input, and I'm going to push a 7 and hit. Now it's got a 7 there. I'm going to hit enter. So now we're looking at input 7 step 1, and recall that was input 7 2. That had the speed command. Notice what's here right now. 7.1 is wait till input 6 is the ground. That's the command that says wait until the detector closes. That, in other words, wait until a streetcar goes in front of the detector, blocks it, and the relay goes from open to closed. That'll satisfy this command. Now the next one, input 7 step 2. Here we are. Notice it says speed forward 4. So let's say we want to set that back to 1 the way the original program called for. I push the program escape button down here in the lower left corner, which takes us back to the main menu. Now I'm going to push 1 for setup, 1 again for input. Input number, it's defaulted to 7, so I'll push 7. I'm going to say step number 2 because that's that speed step. Now I'm going to enter the commands to set that speed back to 1, which is a 3. I'm actually going through a hierarchy menu, but it's easier just to have the numbers memorized. I'm going to push a 3 and then a 2 for speed and a 2 for mode 28 speed steps. Now speed value, I want a 1 here. So I'm going to push enter 1 and push the enter key. Set direction forward, just hit the enter key. So we're done with that. Now it's ready to program input 7 step 3, but we're done. So we're going to push program to escape that. Shut up, Sassy. And then we're going to, now we're back to the main menu. We're going to push review input 7, enter. So there's our step 1, wait till the input goes to ground. Input 7 step 2, there it is, speed forward 1. So you can see we changed that speed from 4 to 1 by doing this. So the point I'm trying to demonstrate is you don't have to have a PhD in computer science to do this. Any elementary school kid can probably learn how to do this. The main website is at AutoControls-dot-org, which hosts these other 2 websites. The documentation is at this site, AutoControls.wordpress.com. That has the drawings, commands, and photos and stuff. And when you get on that web page, look for the documentation for video number 835. That's this video, number 835, and there should be a link that takes you to a Google Drive album which has all this stuff in it.